Definitely technological object that maneuvers, broadcasts a signal or transmits some artificial lights. The Hubble Space Telescope took a very high-resolution image of it, and all we see is some glow.
When the object now known as 3I Atlas entered the solar system, it should have been another brief, forgettable visitor, a speck of ice and dust burning briefly before vanishing back into interstellar darkness. Instead, it broke physics. On the night of July 1st, NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS, picked up a faint moving dot against the background of stars. Its orbit suggested something extraordinary. This was not bound to the Sun. It was the third known interstellar object ever detected after Oumuamua 2017 and Borisov 2019. But what set it apart wasn't where it came from. It was what it did next. A tale that defied physics. Within days, observatories across the globe turned their telescopes toward the new object. Its tail, the luminous wake that defines every comet, did something never before recorded in astronomy. Instead of streaming away from the Sun, pushed outward by solar wind, it pointed toward it. It's like watching a sailboat accelerate directly into the wind, said Dr. Mia Torres, a planetary scientist at Caltech. That just doesn't happen. Images showed the object pulsing faintly red and yellow, then shifting into an intense neon green glow. But most unsettling was its precision. Each time the glow brightened, 3I Atlas adjusted its trajectory. Minute but measurable course corrections that hinted at control rather than chaos. Natural forces don't fire with that kind of regularity, said Torres. Whatever's happening, it's not random venting. The Webb revelation on September 7th, NASA trained the James Webb Space Telescope on the object. Webb's infrared spectrometers are capable of teasing out the chemical fingerprints hidden in light, a way to tell what gases and particles make up distant worlds and stars. What the telescope found stunned researchers. Comets are dirty snowballs, their tails built from water vapor and dust released as they near the Sun. Yet 3I Atlas showed almost no trace of water. Instead, Webb's spectrum revealed a bizarre mixture. Strong carbon dioxide lines, clear cyanide spikes, traces of carbon monoxide, and dense clouds of metallic nickel particles. It was like reading the ingredient list of an engine, not a comet, said Dr. Andrew Lemoyne, a spectroscopist at the European Southern Observatory. Nickel, CO2, and cyanide, together, are not a natural combination in any known cometary chemistry. But they are, curiously, a near-perfect match for gases and metals used in experimental plasma propulsion systems on Earth. When ionized under high voltage, these elements emit a green glow, identical to the one seen in 3I Atlas's tail. The pulse by late September, the phenomenon deepened. The neon plume wasn't constant, it pulsed. Every 232 seconds, the light flared, the radio spectrum shifted, and the object's trajectory nudged slightly. Not by chance, but in sync. To the unaided eye, this was a faint flicker. To astronomers, it was a heartbeat. The precision was terrifying, said Dr. Raj Patel, part of the Minor Planet Center team tracking the object. Nature doesn't keep time like that. Machines do. Each pulse corresponded to a measurable deceleration. Tiny, but cumulative. In just 2 weeks, 3I Atlas had slowed by nearly 1,000 kilometers per hour. No comet in recorded history has ever slowed itself down. Orbital simulations soon showed that its path was bending, threading between Mars and Jupiter, avoiding Earth's line of sight by an eerily exact margin. It's like it knew where we were, said Patel. The hydrogen line, then came the signal. As the green plumes flared, radio observatories listening on wide bands began to detect a tone. A steady hum at 1,420 megahertz, the precise frequency of the hydrogen line. It's a frequency sacred to radio astronomy. the universal language of hydrogen atoms, and the standard channel used by SETI, the search for extraterrestrial intelligence. If any civilization wanted to broadcast a message meant to be recognized across the stars, that's the frequency they'd choose. Each pulse of light matched a spike in the hydrogen line, said Dr. Elaine Chow, a researcher with the SETI Institute. Brightness, thrust, and signal, locked together. Was it a transmission? A byproduct of the propulsion system? No one could say. But comets do not emit structured hydrogen line bursts synchronized with visible light. That's just not a thing, said Chow flatly. An engine in the dark as data poured in. One conclusion began to haunt the scientific community. 3I Atlas behaved like a vessel. Its green glow resembled the exhaust of a plasma engine. Its deceleration and course corrections looked like intentional maneuvers. Its radio emissions suggested an active power source bleeding energy into space. By rough estimate, each pulse of the plume emitted nearly 10 gigawatts, almost half the output of China's Three Gorges Dam, coming from an object only a few hundred meters across. It's absurd, said Dr. Lemoyne. Either nature has found a way to build the most efficient engine imaginable, or we're watching something built by someone else. Some theorized the nickel detected in the plume wasn't dust at all, but structural material, a shell built to withstand extreme heat, protecting an inner core of machinery. If so, 3I Atlas could be a craft, not a comet. The threat for months, astronomers viewed the phenomenon with detached awe. That changed when simulations suggested the object's plume might cross Earth's orbital plane. Webb's spectroscopy showed that the green exhaust was dense with charged particles, cyanide ions, metallic dust, and magnetized plasma bursts. Unlike the solar wind, these weren't harmless. If such material intersected the swarm of satellites orbiting Earth, the results could be catastrophic. Solar panels would short-circuit. Navigation systems would fail. A direct hit could fry entire constellations of satellites, crippling communications and GPS globally. For the first time, NASA quietly began drafting interstellar threat protocols, not for impact, but for contamination of orbital space. This isn't about a collision, said one NASA engineer who requested anonymity. It's about exposure, a plasma plume that powerful could sterilize orbit. Mission: Juno. The response was swift and unprecedented. NASA greenlit a crash-built probe, Juno 1, designed to dive straight into the plume of 3I Atlas. The spacecraft, named in homage to the Jupiter orbiter, would be plated in ceramic nickel alloy to survive the storm of charged particles. Cameras and sensors would be sealed behind layered shielding, designed to capture mere seconds of data before the craft was destroyed. It's a kamikaze mission, said a project engineer. We're flying into the exhaust of something that may not be natural. Unlike long, patient missions such as Rosetta or OSIRIS-REx, Juno 1 would launch within months on a direct trajectory. One shot to capture readings before the interstellar visitor vanished or changed course. Few expected it to survive, but everyone agreed. The data could redefine humanity's understanding of life, technology, and physics itself. A living signal even as Juno 1 strunned Phoebes. G1 was assembled. 3I Atlas continued to evolve. Amateur astronomers began detecting flashes within the plume, faint but rhythmic, like Morse code across the void. Large observatories confirmed the pattern, braided filaments twisting and untwisting as though shaped by magnetic fields. The core glow, once hidden by dust, had sharpened into a constant, brilliant point. Comets blur. 3I Atlas did not. It looked, increasingly, like a reactor running behind a translucent veil. Some models predicted the next phase, a shift to blue-white plasma, the color of ultra-hot discharge. If that happened, the object might decelerate further, possibly entering a stable orbit between Earth and Mars. Interstellar objects aren't supposed to stay, said Torres. But this one might. And that's the part that scares everyone. The existential divide, the debate now fractures along existential lines. If 3I Atlas is natural, then it reveals forces in nature far beyond human understanding. Processes capable of mimicking engines, signals, and intelligent design. If it isn't natural, then it's something far more consequential. The first known active alien machine in our solar system. We always imagined first contact as a conversation, said Dr. Chow. What if it's just an object, silent, deliberate, already here? The hydrogen hum still pulses every 232 seconds. The green light still burns across the void. And somewhere between Mars and Jupiter, an interstellar visitor continues to steer, quietly rewriting everything we thought we knew about comets, about machines, and about what might already be watching us from the dark.